Hello and welcome back to Mech Vision. Aviation has been at the forefront of tech advancements, pushing the boundaries of engineering, physics, and design to meet the ever-growing demands of efficiency, speed, and capability. Over the years, countless aircraft concepts have been proposed. Some made it into production, while others remained mere blueprints of what could have been. From colossal cargo planes to next-gen fighter jets, innovative personal flying machines, and revolutionary propulsion systems, the aviation industry continues to explore uncharted territory. This article delves into some of the most fascinating aviation projects, both realized and conceptual, that have shaped our understanding of what the future of flight holds. In the early 2000s, Boeing envisioned the Pelican, a conceptual design for an enormous ground-effect aircraft intended to carry unprecedented cargo. This behemoth was designed with a wingspan of 500 feet and a length of 400, making it one of the largest aircraft concepts ever conceived. It was projected to carry 1,400 tons of payload, dwarfing the capacity of contemporary cargo planes. The Pelican was meant to exploit the ground effect, a phenomenon where an aircraft flying close to the surface benefits from increased lift and reduced drag. Although primarily designed for flying at low altitude over oceans, it could also operate at higher altitudes like a conventional aircraft. Despite its promise, though, the project never advanced beyond the conceptual stage. However, it showcased Boeing's forward-thinking approach to solving logistical challenges. The sixth-generation fighter jets represent the next step in aerial combat, surpassing the capabilities of their fifth-gen predecessors. These aircraft are expected to be highly interconnected, utilizing AI for autonomous decision-making and electronic warfare that allow them to operate in contested airspace. Innovations in propulsion systems might include hypersonic speeds and directed energy weapons, further cementing their superiority. In addition, those jets may incorporate stealth enhancements, improved sensor fusion, and the ability to operate with or without human pilots. The ultimate goal of these aircraft is to dominate the battle space with superior speed, agility, and information warfare, ensuring air superiority well into the future. During the 1970s, the Soviet Union sought new ways to transport heavy equipment across vast, inhospitable regions, like Siberia and the Far East. Standard helicopters, like the Mi-6 and Mi-10K, were inefficient for such demands, prompting the Mil Design Bureau, in collaboration with Sagi, to conceptualize the Mi-32, a twin-rotor helicopter capable of lifting 55 tons. Using components from the Mi-26, this helicopter aimed to serve both military and civilian needs. Despite rigorous research and positive wind tunnel testing, the project never came to fruition, leaving the Mi-32 an unrealized milestone. NASA's X-Plane, the quiet supersonic revolution. NASA has been actively developing the low-boom flight demonstrator, an experimental X-plane designed to achieve supersonic speed while minimizing the disruptive sonic booms traditionally associated with breaking the sound barrier. Current regulations prohibit supersonic commercial flights over land due to noise concerns, but NASA hopes that this aircraft will demonstrate a quieter alternative, enabling future high-speed passenger travel. The aircraft's uniquely shaped fuselage helps disperse shockwaves, preventing them from merging into loud booms. The X-plane will be tested over select U.S. cities to gauge public acceptance and pave the way for potential supersonic air travel. An ambitious and futuristic design represented a bold attempt to rethink conventional aircraft aerodynamics. This unique circular wing, which wrapped around the fuselage, was intended to create a continuous flow of air, reducing drag and increasing fuel efficiency. The elimination of traditional wingtip vertices, which contribute to drag in most aircraft designs, was a key frame of this concept. The design aimed to improve not only fuel efficiency, but also the overall stability of the aircraft, especially in turbulent weather conditions. Despite its potential, the ring wing concept was never developed beyond the prototype stage, primarily due to challenges in manufacturing, structural integrity, and public acceptance of such a radical design. Nonetheless, it remains a fascinating exploration of what could have been a revolutionary leap in aviation tech. Gyroplane Nissus, a modern autogyro. A modern twist on the autogyro concept, which has been around since the early 20th century. By using an improved rotor for lift and separate propulsion system for forward motion, the Nissus offered a more fuel-efficient and mechanically simpler alternative to traditional helicopters. This design made it more cost-effective while providing versatility required for urban mobility, emergency medical services, and reconnaissance. Although it remained an experimental concept, the Nissus demonstrated the potential for autogyros to play a role in future aviation, particularly in crowded urban environments where traditional helicopters might be impractical. Lockheed C-130 Hercules, a timeless workhorse. First introduced in the 50s, the Lockheed C-130 Hercules has become known as one of the most widely used military transports in history, serving over 60 nations. Known for its versatility and durability, the C-130 can perform a range of missions, including troop and cargo transport, medical evacuations, aerial refueling, and humanitarian aid. Its ability to operate in harsh conditions, including short and rugged airstrips, has solidified its place as a cornerstone of military aviation. Modern variants continue to incorporate advanced tech, ensuring its relevance for decades to come. Renault Air 4, a flying tribute to the past. To celebrate the 60th anniversary of the iconic Renault 4L, Renault unveiled the Air 4 concept, a visionary reimagining of the classic vehicle as an electric flying car. Designed with a lightweight carbon body and four drone-like propellers, the Air 4 blends nostalgia with futuristic tech. As a fully electric vehicle, it highlights Renault's commitment to sustainable innovation in aerial mobility. Although it remains a concept, the Air 4 is more than just a tribute to the past. It represents the potential for transforming urban transport. The Air 4 envisions futures where vehicles no longer travel on roads, but soar through the air, providing a glimpse into how electric flying cars could redefine mobility in congested cities. Skyrider X1, the amphibious flying motorcycle. Unveiled at CES in Las Vegas, the Skyrider X1 is a groundbreaking amphibious flying motorcycle designed to be a personal, versatile mode of transport. Functioning as a street-legal moped on the ground, it transforms into a flying vehicle with the help of 8 coaxial propellers. The Skyrider X1 can take off vertically, offering a top speed of 62 miles per hour and a flight time of up to 40 minutes. Its amphibious design allows it to navigate water, making it perfect for both land and aquatic environments. The Skyrider X1 is an innovative solution for urban commuters, combining convenience, speed, and the ability to bypass traditional road congestion, potentially reshaping how people think about personal mobility. Solar Impulse 2, a milestone in renewable aviation. The Solar Impulse 2 is marked as a historic achievement in aviation when it became the first aircraft to circumnavigate the globe using only solar power in 2016. Equipped with more than 177,000 solar cells embedded in its wings, this ultralight aircraft demonstrated the potential of renewable energy in the aviation industry. Solar Impulse's 2 journey not only showcases the viability of sustainable aviation, but also highlighted how solar power can facilitate long-duration flights without relying on conventional fuel. By pushing the boundaries of renewable energy tech, Solar Impulse 2 made a bold statement about the future of aviation, offering a glimpse of how green tech can help reduce the environmental impact of flight. From conceptual designs that never took off to revolutionary projects that changed aviation forever, the world of aerospace engineering remains an ever-evolving landscape of innovation and ambition. While some of these aircraft remain in the realm of speculation, they each contribute to the progress of flight tech, pushing humanity closer to a quieter, more efficient, and environmentally friendly aviation solutions. As engineers and visionaries continue to reimagine the future of air travel, these remarkable concepts serve as an inspiration for the next generation of aviation pioneers.